name is Victor, and today I'm going to show you how to solve a radical equation using a slightly more difficult example. Okay. Now in the previous video we went over radical equations, we went over radicals and their indexes, right? So knowing that, let's go ahead and go into this example. Let's say we had the square root of x minus 1 equals x minus 7. Okay. Now, when you're solving for radical equations, you always want the radical to be by itself on one side. So in this case, the radical is already by itself on the left side, right? The square root's already alone. So what you want to do is you want to go ahead and take this radical, or the root, and raise it to the power of what the index is. So in the previous video, we noticed how the index of a square root is always 2. So I'm going to go ahead and raise this to a power of 2. Whatever I do to one side, we do to the other side. So I got to take the whole right side and raise it to a power of 2 as well. Right? So this power of 2 would cancel out with the square root, and we'll be left with whatever is inside the radical. So in this case, we would have x minus 1 equals x minus 7 squared. That means that I have to do x minus 7 times x minus 7. Right, so we have to FOIL here. So in this case, we would do x times dx, would give us x squared. X times the negative 7 would give us negative 7x. Right, then we would do the negative 7 times dx, would give us another negative 7x. Negative 7 times negative 7 would give us a positive 49. And on the left side, we have the x minus 1. Right, so on my right side, let's go ahead and combine like terms. I have my x squared. Negative 7 minus 7x gives us a negative 14x, right? And then we have the positive 49. And on the left side, we have the x minus 1. Now, we went from going from a radical equation to now making it look like a quadratic equation. Now, with quadratic equations, we can always solve by factoring. And to factor, you want everything on the same side. So I'm going to subtract x and add 1 to cancel both of these. Whatever I do to one side, we do to the other side. So I have to subtract x on the right side and add 1 also to the right side. On the left side, we're left with just a 0, right? Because everything canceled out. On the right side, we have x squared. Then we have negative 14x, and negative 1x gives us a value of negative 15x. Then positive 49 plus 1 gives us a value of positive 50. Okay. Now we want to go ahead and solve this by factoring, right? And the way that factoring works is we want two numbers that multiply to each other and give us the 50, but when we add those same two numbers, they give us a negative 15. Okay, so two numbers that multiply to each other and give us 50, but when I add those same two numbers, they give me a negative 15. Now the numbers that would satisfy this would be negative 10 and negative 5, because negative 10 times negative 5 does give us positive 50, and negative 10 plus negative 5 gives us a value of negative 15. So negative 10 and negative 5 are the numbers that we want to use to factor. Right, so to factor the first term right here, this x squared, it would just be x times ex. Right, and then we have our minus 10 and we have our minus 5 equals 0. Right, after you factor, you take each factor and set it equal to 0. So I'm going to go ahead and take this factor of x minus 10 and set it equal to 0. And I'm going to take this factor of x minus 5 and set it equal to 0 and solve for x. So starting with the x minus 10, we would simply add 10 to both sides, cancels that, x equals 10, right? And on my right side, where the x minus 5 is at, I would add 5 to both sides, so x would equal positive 5. So far we found two answers. We found that x equals 10 and x equals 5. Now you always want to check your answers, okay, when dealing with radical equations. So what we're going to do is we're going to rewrite our original equation, which was the square root of x minus 1 equals x minus 7. And I'm going to replace all my x's with a 10 and with a 5. Okay, so let's go ahead and test out the 10. So this x would become a 10 minus 1 equals 10 minus 7, right? And on the other side, I'm going to go ahead and write the square root, and now I'm going to use the 5. So it's going to be 5 minus 1 equals 5 minus 7, right? So on the left side here, where the 10 minus 1 is at, that gives us a value of 9. So underneath the radical, we have 9 equals 10 minus 7. The square root of 9 gives us a value of 3. And 10 minus 7 gives us a value of 3. So 3 does equal 3, so that means that x equals 10 is a correct solution. Now let's verify the 5. We know 5 minus 1 gives us a value of 4 underneath the radical. And then we have 5 minus 7. The square root of 4 gives us a value of 2. And 5 minus 7 gives us a value of negative 2. So this is not a true statement. 2 does not equal negative 2, so therefore this answer, x equals 5, is not a correct answer. Our only answer would be x equals 10. Okay? So there you have it. That's a slightly difficult example dealing with radical equations. Any questions or comments, you may leave them below. And have a good day.